In chemistry, we are more interested in the valence electrons, those electrons in the outermost shell. Those electrons are the ones that interact during a chemical reaction. They can be gained, lost, or shared during a chemical reaction. The electrons in the outermost shell are affected by two major forces, attraction force and repulsion force. First is the attraction force between valence electrons and the positively charged nucleus. Usually the presence of completely filled orbitals causes a shielding effect. The inner electrons shield the attraction force coming from the nucleus towards the valence electrons, which minimizes the effect of attraction force and makes it easier to remove valence electrons. As for the repulsion force, the repulsion between electrons increases as we go far from the nucleus, which also contributes to the easiness in removing the valence electrons. The simplest method to represent valence electrons is by using Lewis dot structure. The Lewis dot structure or Lewis structure represents valence electrons as dots surrounding the sample of the element. For example, here we have carbon that has 6 electrons. The electronic configuration of carbon in the ground state, like we saw before, 1s2, 2s2, 2p2. The 1s electrons are considered to be inner electrons, and the 4 electrons in the 2s and 2p are the valence electrons. The Lewis structure that represents carbon is a carbon sample surrounded by 4 valence electrons. Usually the valence electrons are distributed around the element sample. Dots represent the valence electrons that are written as pairs. Here are some of the Lewis structure of elements in periodic table. You can see the first group has 1 dot, 1 valence electron. The second group has 2 dots, 2 valence electrons, and so on.